Now, the materials, as far as their properties regarding the charges and the movement of charges within these materials are usually divided into three main categories. The first category in this case is the conductors. Now, conductors are materials in which some of the electrons, usually the valence electrons, the outermost electrons in atoms, are free and are not bound to the atoms. So in a conductor, when the atoms come to form a material which is conductor, they donate their outermost electrons to the whole material. They do not keep that electron for themselves. This is why I usually sometimes call conductors as believing as those who are materials who are communists. They do not believe in private properties. Okay, so they donate their electrons for the whole community of atoms that are around. And so this is exactly what happens. You have the atoms coming together, donating their outermost electrons, or some of them, so that electron move freely throughout the whole material. So there's a cloud of electrons, and you do not, and these become just common during that, or throughout that material. So this is what a conductor is. Now, they move relatively freely, so they are like just free electrons wandering throughout the material. And these are some examples of good conductors like copper, aluminum, silver. These are examples of these conductors. Now, another very important property of conductors, because the electrons here can move freely, it explains a lot actually of the properties of the conductor, is that when you have a charge in a small region of an excess charge in a small region of the conductor, then in this case that charge distributes itself over the entire surface of the conducting material. Okay, so what does this mean is that if you have originally neutral, for example, sphere of silver, for example, and you add some electrons to this sphere at some point, then these electrons will not remain there. They will just, the charge appears on surfaces of conducting materials. The same applies when you extract some electrons from one part of the surface of that of the material. In this case, you will have a deficiency of electrons there, but that deficiency will not remain here. Actual electrons will come from other parts of the material, and this deficiency will redistribute itself over the whole surface of the material. Now, this deficiency means what? Means excess of positive charge. So a positive charge in this case will appear on the surface of that material. This is this is a property of conductors, and the reason, as you can easily see, is that the electrons are not bound to the atom, and they can move almost freely through the material. Now, on the other side, we have the contrary. We have insulators. Well, insulators, those are materials that believe in private properties. Okay, so they are capitalists. They are the counterpart of, or the other extreme to communists. And in these materials, all the electrons are bound to the atoms. Atoms do not bound their electrons. They do not donate their electrons. They keep their electrons to them. And the electrons cannot move freely through the material in this case. And examples of good insulators are glass, rubber, and wood, for example. And as a consequence of this, then in this case, when a good insulator is charged in a small region, that is when you add or take electrons from some small region, then the charge is unable to move to other regions of the material. So if you have if you charge one end of a glass rod, for example, the charge will remain there. It will not move and spread through the whole rod, for example. Okay, so this is an important property of insulators. And of course they are insulators because, as you know, they do not conduct electric current, and they are also bad conductors of heat, for example. Of course, all of this, the reason for all of this actually is the electronic structure and the fact that the atoms keep their electrons bound to them. Now, there is a type of material which is in between conductors and insulators, which we call the semiconductors. And examples of these materials include silicon, germanium, and these are crucial for the electronic industry, digital industry actually, because they are used in making electronic chips. And the electrical properties of these materials can be changed by adding some other atoms in a process that we called doping.